For centuries, humans have pondered one of the most profound questions in all of cosmology. Does the universe have an edge? And if it does, what lies beyond it? Let's imagine something together. You're aboard a futuristic spacecraft, leaving Earth far behind, accelerating toward the speed of light. You have unlimited fuel, an eternal lifespan, and no destination but outward. How far could you go? Would you hit a cosmic wall? Would you pass through it? Or would there be nothing at all? These questions, as simple as they sound, strike at the very heart of our understanding of space and time. Looking into deep space is looking into the past. To answer this, we need to first understand how we see the universe. Even when you look at someone nearby, you're seeing them as they were 3 nanoseconds ago, the time it takes for light to travel a meter. Now scale that up. When we look into deep space, we're not seeing galaxies as they are now, but as they were millions, or even billions, of years ago. Take Andromeda, the closest major galaxy to the Milky Way. It's speeding toward us at 400,000 kilometers per hour. Yet we see it as it looked 2.5 million years ago. This limitation defines what we call the observable universe, the region from which light has had time to reach us since the Big Bang. The universe is about 13.8 billion years old, but because of cosmic expansion, we can actually see 46.5 billion light-years in all directions. That means the observable universe spans about 93 billion light-years in diameter. But this isn't the edge of everything. It's just the limit of what light has reached us so far. Could a spaceship ever reach the real edge? Now imagine this. A thought experiment from astronomer David Kipping. Suppose your spacecraft could accelerate forever, at a constant 10 meters per second squared. That's equal to the gravity you feel on Earth. This would make the trip comfortable. No floating, no spinning, just normal gravity inside the ship. In just 1 hour, you'd be traveling at 36,000 kilometers per hour. In a week, you'd pass Saturn. In 11 days, Neptune. And in about 15 months, you'd be 1 light-year from Earth. But now, Einstein enters the picture. Relativity changes everything. According to special relativity, nothing with mass can ever reach the speed of light. No matter how much energy you pour into your ship, you'll only get closer and closer to light speed, but never touch it. And there's another twist. Time itself begins to slow down for you. Not from your perspective, but to observers watching from Earth. At 90% the speed of light, time passes twice as slowly for you. At 99.999999951%, the speed of a real cosmic particle called the "oh my god" particle, time slows down by a factor of 300 billion. To the particle, a journey spanning millions of light years feels like it only takes minutes. This is time dilation. And it's very real. So where is the limit? As you keep accelerating, you'll eventually cross a point of no return, about 3 billion light-years from Earth. Beyond this point, dark energy causes the space between you and Earth to expand faster than light can travel. It's not a wall. There's nothing to crash into. But if you turn around and try to come back, you'll never make it. The universe stretches faster than you can fly. This invisible boundary is called the cosmic event horizon. Anything beyond it can never contact us again. Not now, not ever. Different zones of the universe. Cosmologists divide the universe into 4 conceptual zones. Reachable universe, up to 15 billion light-years away. These galaxies, about 660 billion of them, could be reached, if we could travel fast enough. Visible but unreachable, from 15 to 46.5 billion light-years. We can see these galaxies, but we can never get to them. currently invisible universe, from 46.5 to 61 billion light-years. Their light is on the way, and will become visible in the far future. Permanently unobservable universe, beyond 61 billion light-years. Their light will never reach us. Ever. In truth, 96.7% of all observable galaxies will eventually vanish from view. Not because they're destroyed, but because the universe is expanding too fast for their light to ever catch up. The fate of the universe. What happens in the very far future? Stars will run out of fuel. Atoms will decay. Black holes will evaporate. Eventually, only dark energy will remain, pushing the cosmos apart forever. If you were still in that spaceship, you'd be flying through eternal darkness. No stars. No galaxies. No edge. Just nothing. Is the universe finite or infinite? Back to our original question. Does the universe have an edge? The answer depends on its shape, a concept rooted in Einstein's general relativity. There are three main shapes the universe might have. Positive curvature, like a sphere. The universe is finite, but has no boundary. Travel far enough, and you'd loop back to where you started. Negative curvature, like a saddle. The universe is infinite and open. Flat geometry, like a plane. Still infinite. Still no edges. And what do the measurements say? Data from the cosmic microwave background tells us the universe is flat, to within 0.4% margin of error. This suggests the universe is spatially infinite. No edge. No center. No boundary. Strange topologies and the shape of everything. Some scientists propose the universe may have a looping shape, not unlike a dodecahedron or a torus. Imagine flying in one direction, and eventually returning from the other side, just like walking around the Earth. But so far, observations favor a simple, flat, and infinite model. The truth is, we don't fully know. Conclusion: no edge, just expansion. So, does the universe have an edge? If you're looking for a wall, a border, a place where space just ends, no. There is no such edge. But if you mean the edge of what we can see, or reach, or influence, then yes, there are limits. The observable, the reachable, the causal, and they're slipping away from us, faster than we can ever chase. In the end, it's not about reaching the edge of the universe, it's about understanding it. Space, time, energy, and light. They define where we are, in the greatest story ever told.